Hello, welcome back to the last section on the regression for this week. And in this part, I'm talking about logistic regression. So what is a logistic regression? Why do you care? Why do we need it? Well, sometimes when you have a study, your dependent variable is measured in categorical scale, but you want to do a regression on it. So this type of regression is usually used to predict a probability of an outcome to occur or not occur. Like you want to predict whether someone, what would predict someone to die or live long? What would predict someone to have a cancer, high or low? What would something that would predict a company to be very successful or not so successful? So if your variable is that type of categorical, then logistic regression is the best method. So one example is here. You want to know the probability of people getting lung cancer. 1, yes. 0, no. So you capture whether a person has that or not from your data, and you want to know whether when every person who is above every kilogram above the overweight standard, and the person's cigarette consumption per day, what is the effect of this extra kilogram of weight and the cigarette that they smoke on the probability of getting lung cancer? Then you will use logistic regression. You can't use multiple regression. Here you have two independent variable, but your dependent variable here is not a metric or continuous scale, but it's in categorical scale or nominal scale. It's 1 and 0. So in linear regression, you have that straight line that you're trying to produce, right? To use X to predict Y, right? But in so it's typically straight line. Now in logistic regression, that regression line is called an S curve. It has this sort of curve. So the curve is between 0 and 1. So you want to predict whether an outcome or event occur or not, whether someone wins election or not based on the citizens who are voting for them. So you want to know what makes a particular politician to win in an election. You want to know what makes a singer to be very popular and not very popular. So use this kind of logistic regression. So there are some mathematical expression to express that probability. So the logistic regression is somehow similar to the previous equation for regression, like bivariate or multivariate regression, except that use a logit. And that logic is the probability. And there's some formula to calculate this, but you will not worry about this because we're not going to calculate this by hand. So some issues with this logistic is you need to know that you can overfit easily because you put too many variables, that the model becomes what we call overfit. So this is something that you need to be aware of. And you need to know the goodness of fit to see whether your logistic regression fit with the data. And one of the most commonly used is called Horstmer-Lemaître goodness of fit. So actually you want this to be not significant to suggest that there is a model fit. And there's a formula to calculate the Horstmer-Lemaître goodness of fit, or GHL square. And another important output in logistic regression is the Cox and Snell R square and Nagy-Kölkey R square. So these are the measures of fit. It's kind of R square. It's kind of an R square in bivariate and multiple regression, but the interpretation is slightly interesting. So here I use a dataset called binary.sav, which you can download it down there at the bottom. And they're trying to understand what factors predict people to get admitted into the graduate school. So the variable admit is the DV, dependent variable. So if a person is admitted, they give a score 1. If the person doesn't get admitted, it scores 0. So the DV, dependent variable, is categorical, 1 or 0. Right? And the IVs are the GRE, is a graduate record examination, and the GPA of the school and rank of the school where this person used to study. So we treat the GRE GPA as a continuous variable, and the variable rank as a kind of ordinal scale, if you like. So 1 to 4. So you enter that into logistic regression. So you go for regression, binary logistic, and you enter admit as a dependent variable, and then you have three variables that you enter for the independent variables, and you have this result. So first we look at the omnibus test results. The bottom one, the one that has model and has a chi-square and is significant. So it means that, so why do you have this omnibus test? Because in logistic regression, they always produce a base model or model 0, and then they have omnibus tests with the overall. So what this is saying is they give a comparison between the overall model that you're testing with the base model. Base model is when you have no predictors at all. So this is, I don't know why, but SPSS always produce the base model, a basic model, or model 0. So what it says here, this model is better than the base model or the null model, right? So it has chi-square 41.4 is significant. And look at the Hosmer-Lemeshow test is not significant. I mean, the model fit the data, and this is very good. And look at the model summary. So the R square for this logistic regression is between 0.09 to 0.13. So actually the value is not very big in terms of R square, but this is not like conventional R square in terms of the bivariate or multivariate regression. The key part is actually the beta value and the percentage of classification, percentage of correct prediction. Look at that. So whether someone get admitted 0, get admitted 1, or not admitted as 0, look at the classification table there. It has a 71% overall percentage. So this says that this model correctly predicts 71% of the cases. So which is pretty good, right? So it's more than 50%. So 71% is pretty good. And the variables in the equation table, it shows you the beta value and the significance. So you can see that GRE is significant, less than 0.05, right? It's only 0.038, but the beta value is 0.002. So it has some effect in predicting the probability of someone get admitted to the graduate school. But look at the GPA, it is very big, 0.804, and is significant, less than, so it's 0.01, 0.015, which is lower than 0.005, lower than 0.05. So it is quite big. So, but the rank of the institution seems even bigger, 1.551. So you interpret this in terms of every unit increase of GRE for the GRE has a 0.02 higher chance of being admitted into graduate school. And every unit increase in GPA has a 0.8 of higher chance of being admitted. But starting in rank 1 institution has a 1.55 high chance of being admitted into the graduate school. So this is how you can see which variables are more important based on the beta value. So the higher the beta value means the more important is the coefficient and they're significant. So this is how you see the, and this is how you write the regression formula, right? So logit equals to minus 5.54. This is the intercept. 5 minus 5.54. Look at the bottom there. Yep. And then the GRE is 0.02, 0.02 multiplied by GRE, and 0.8 multiplied by GPA, plus 1.551 multiplied by rank 1, plus 0.87 rank 2, and 0.21 multiplied by rank 3. If I give you a question, what is the chance of someone who have a GRE of 300 and GPA 3.5 and from rank 1 university to be admitted into the graduate school? Then very simple, you just add that number, 300 multiplied by 300 is GRE, right? 300 multiplied by 0.02, and then you add that with GPA of 3.5 multiplied by 0.8. Right? Look at the formula, and then rank 1 is rank 1 is 1.551, and you remove the rest. Rank 2 and rank 3, it becomes 0. So minus 5.54 plus 0.02 multiplied by GRE is 300, plus 0.8 multiplied by GPA is 3.5, plus 1.551 multiplied by rank 1 is just 1. And you add up that logit P, logit in bracket P has a value of 4.811. So the question is, what is the probability of having a positive outcome of being admitted to graduate school with that value of logit equals 4.811. You can enter an equation, or you can use the scientific calculator exponentiated of x. So you can use your scientific calculator, or you can use the calculator in the link below. You enter. So when you enter 4.881, it gives you a value of 122.85. So then you have, so that 122.85 is the exponential of that value, of certain value. So then you have 122.85 divided by 1 plus 122.8, and then you get a value of 99.19. So the one that I highlighted in color. So if someone have GRE of 300, GPA of 3.5 from rank 1 university, then this person have a 99.19 chance or probability of being accepted into the graduate school. Is it good or not? Of course it's good. It makes sense because actually GRE, you can have a look what is the maximum value of GRE. GRE has maximum value of 340. So 300 is considered very high. GPA 3.5 is also considered very high. Out of scale of 4, right? It depends on what scale you're using. And rank 1 university is rank 1 school is also very high rank, right? So if someone has all these variables, he has a 99% chance of being accepted into graduate school. So this is how you look at the result. There's also a discussion on structural equation modeling. I will not talk much about this, but structural equation modeling is used when you have multiple regression. You have multiple equations that you want to estimate together, and you can't use this using SPSS. You need to use a specialized software called AMOS, or you can use R, you can use Python, you can use MATLAB, you can use many different types. But this is one example. You have very complex relationship, and you want to test this. And you can only just test this using SEM. So there's a certain procedure to test it, and this will be discussed in later in week 9. So to put this to conclusion, so regression is a very useful tool to test and validate a theory, your research model, right? So regression is to predict dependent variable using a number of independent variable. When you have only one independent variable, it becomes just a bivariate regression. When you have multiple independent variables, more than 2, then you use multiple regression. So one of the key assumptions of multiple regression is the linear assumption, the linearity, and the normal distribution. So because when your variables are not linear, you cannot use this. Linear means it goes up. When it becomes like this, when it comes like this, then it's you don't use regression, you use something else, right? So in simple regression, you have the equation like that: y equals b0, the intercept, plus the slope b1 multiplied by the variable called x1. And the multiple regression is the same, but you have more x's and more b's, so b1, x1, b2, x2, b3, x3. In logistics regression, you have a logit very similar with the b1, x1, b2, x2, but it's just use a logit function. And you need to check the scatter plot, you need to check your correlation, you look at the R squared, the F statistics, the beta, the p-value. So with SPSS, it makes your life easier to do the regression analysis. That's it for today. Bye.